Okay, so let's look at this problem. We have the limit as n approaches infinity of the summation from k equals 1 to infinity of 2 times the quantity k over n plus 3 times 1 over n. So 1 over n we know is going to be our change in x. So once again, we're going to do 1 over n is equal to b minus a over n. This means 1 is equal to b minus a. So the difference in our interval is 1. Everything inside of our parentheses here that's with k over n, this is going to be the inside of what was f of. So f of a plus k delta x, the inside of these parentheses is the same as the inside of our other parentheses. So we have k over n plus 3 is equal to a plus k delta x. We know delta x is 1 over n. So we have k over n plus a is equal to 3 plus k over n. If I subtract k over n from both sides, we get 3 is equal to a. Our difference in our interval is 1. We know a is 3. So b minus 3 is 1, so we know b has to equal 4. So we have our integral from 3 to 4. Because all of this stuff is also the x in f of x, we also have all of that is just x for us. So we have 2 times that, so 2 times x and dx at the end. So when we're doing this here, going into writing our integral, we end up simplifying a lot of things. The big key here is just identifying k over n is literally going to be an x every single time in our problem. 1 over n is that change of x. Now, if we have to go the other way around, we start with our integral, we're going to write the limit of it. So this is equal to, we know we need the limit as n approaches infinity. Let me get in a little closer. So the limit as n approaches infinity. We know we need sigma. We need k is equal to a number. That number is going to be 1 for us. And it's always going to go to n because we need our number of squares to go towards infinity. Now, we have f of a plus k delta x times delta x. So I'm going to keep everything that stays the same. So our limit as n approaches infinity stays the same. Sigma k equals 1 to n stays the same. Let's plug in some of the stuff we know. So a is 0 because it goes from 0 to 3. So I know a equals 0, b equals 3. So 0 plus k times delta x is b minus a over n. So b minus a over n times delta x again, so b minus a over n, and we're going to plug in our values, so 3 minus 0. So we have the limit as n approaches infinity of sigma k equals 1 to n. Let's simplify our function. So we have 0, we can get rid of it, k times 3 minus 0, 3 over n. So we have 3 over n times k, so 3k over n. 3 minus 0 gives us 3 over n. Now we're going to do one more thing here, which is plug in our function. So the limit is n approaches infinity of the summation from k equals 1 to n. We need to figure out what our function is. So our function in this case, x squared minus 1. So if I were to write that out, I'm going to put a parenthesis for everything where f of x is going to be. We have our 3 over n that just pulls down. So our function is x squared minus 1. Well, instead of x, we have 3k over n. So I'm going to put in 3k over n. And that is my function. So I have the limit as n approaches infinity of the summation from k equals 1 to n of the quantity 3k over n squared minus 1 times 3 over n. The biggest part with this is just being able to recognize what parts and pieces we need, how they interact with each other. I think the big one would be taking something that looks like this and changing it to the definite integral, but being able to change back is also a little bit helpful.